Okay, so today we'll be learning about probability. Now, probability is very important. Just like your linear algebra, probability plays a crucial role in a sense that if linear algebra converts your system of linear equations into matrices, okay, and then the matrix computation is done, what probability does is it tries to understand the results obtained, okay, even before the results that are obtained, even before the training happens. Prior to that also it tries to understand the data. So basically, before training and after training. Before training is understanding the data, how the data is coming, as in the what constituted the event or the outcome. That is what probability talks about. And after training, the results that you get, okay, so to calculation of confidence, maybe calculation of confidence intervals, even the result themselves are probabilities, to be honest. You don't get a exact value, you rather get a probability. To make sense of those, you need to understand how probability works. Now probability is nothing but just the it's a branch of mathematics where it deals in understanding the likelihood of occurrence of an event. Okay, so what is the possibility? Probability is actually can be equated to possibility. So what is the possibility of some event can happen, okay, randomly, or sometimes weighted event. Okay, so in either case, what is the probability of certain outcome, okay, versus divided by total number of outcomes. For example, I have four pair of clothes. I wear red t-shirt. What is the probability that I will wear red t-shirt on Monday? What is the probability versus if you calculate that out of four t-shirts? Okay, so the probability of me wearing a t-shirt, red t-shirt on Monday is 1 by 4 because I have four
Therefore,
t-shirts. Yeah, yeah,
yeah,
yeah.
yes.
And if you want to calculate that for 7 days, then you'll have to also multiply, sorry, divide by 7. Okay, so
1 by
1,
7 into 1 by 4.
correct. So that would become
Mm.
your probability. So that is what we are going
Mm.
to talk about. Now there are some important terminologies we need to understand. Experiment, the whole operation that we do, may it be tossing of the coin, may it be calculation of what t-shirt I'm going to wear, so that will be called as experiment. Okay, now experiment you will also again encounter again when you do the model training. Okay, before training the model, you will test with various parameters. Okay, what will happen if I tweak this parameter? Will I get better results in the model of training? If I use another parameter, tweak another parameter, decrease or increase. So there are a lot of parameters and hyperparameters that we will talk about in machine learning. But for now, there also you will get the same key word. So experiment is nothing but the operation where you want to do some manipulation and get the outcome. Or even if you don't want to manipulate, just want to try out some results, so that is experiment. Now sample, even before going to sample space, you have to understand what sample is. Again, this will learn in statistics, but here, just to get easy understanding, sample is nothing but, so let's just say there are million colors of t-shirts in the world. Out of those t-shirts, I only own four color t-shirts. Okay, out of million designs and colors of t-shirts, I have only four t-shirts. Okay, so now the entire million design or colored t-shirts will be called as population. Okay, and you're taking a small chunk of that population, and that is called as sample. So here, if you toss a coin can have only two sides, head or tail. So population is head or tail only, and sample is either head or tail, one of a small chunk of the entire population. So that is called a sample. Now, when you, with each time you repeat the experiment, you may get a small outcome. Okay, and that if you keep on collecting those outcomes in a set, first time you got heads, then you got tail, then you got head, then you got tail, so then you got head that way. So if you collect all of these, okay, that will be called as, if you collect the outcomes, basically if you collect the outcomes, that will be called as outcome space. And but if you collect only what are the different possibilities that can happen, either head or tail, so if you talk about only those, then that will be called as your sample space. Okay, sample space is nothing but the again, there is small difference here, okay, between sample space and outcome space. Outcome space is the result, you keep on collecting the result. First I tossed the coin, I got head, so the result that you collected, that became your outcome space. The sample with which you tried that experiment became your sample space. Okay, so all the possible, here they have used the word outcomes, that's why don't get confused. Sample space, if you use somewhere else, okay, uh, sample point, okay, so here also they are using the same thing. Okay, sample space is this 1 2 3 4 5 6, because there are only 6 sides to a die. But if you start rolling the die, first time you got 1, say next time you got 6, next time you got 1, next time you got 2, next time you got 4, next time you got 3, that way if you keep on collecting the outcomes, that will become your outcome space. Okay, so that is the difference here. It is not very well represented, but anyway, so now favorable outcome is, you are very sure that you will get certain result. Okay, some expected event will happen. Okay, so that will be called as favorable outcome. Now in this example, although this is not a good example again, because you can't be sure that you will get these numbers only, but anyway, so when you roll the dice, favorable outcomes is nothing but the sum of the dice. If you roll the dice twice, let's just say you got initially you got 6, then you got 1, then the sum of these two numbers is 7. Okay, so if you calculate um, all the times you roll the die and all the calculations you do, certain number of times you will get 7. Okay, so maybe 5 and 2 you will get, maybe 6 and 1 you will get, maybe 3 and 4 you will get. So that way when you calculate the sum, okay, though you are very sure that sometimes, okay, if you roll the dice 10 times, maybe you are very sure that you will get the sum as 7 at least like 1 or 2 times minimum. So that will be called as desirable, sorry, that is called as favorable outcome, because you are kind of expecting it to happen. um, so yeah, so one more example is, if you wrote an exam,
Mm-hmm.
securing 35 marks is easy. Okay, you're sure that you have covered up to 80% of the paper, and here the favorable outcome is pass marks. Okay, you're sure that you will pass. Okay, um, and a better result could be you're getting a first class or distinction, or securing top of the college. So that way, okay, so favorable outcome is where you are expecting the, where the expected event will happen. Okay, so that is what trial is. Again, a random experiment. So experiment we already talked about. Experiment and trial, they can be used interchangeably. So trial is doing the experiment randomly. Okay, random experiment is a trial. Now event is, you're, after doing the random experiment, it could be any outcome. Getting a outcome after conducting a experiment, that is called an event. Now not necessarily whatever the we are not concentrating on the outcome, but whatever the outcome is, if you just conduct the experiment, you get the outcome. Okay, that is called as event. Okay, and equally likely events are nothing but, so you know before conducting the experiment, okay, you know that the probability of you getting a result you already know. Okay, for example, if you toss a coin, you already know either you will get head or tail, so the probability of you getting head or tail is only 50%. That can't change. So and again, next time you toss the coin, again you know the probability of getting head or tails is again 50% only. Okay, so irrespective of how many times you try to conduct the experiment, the probability doesn't change. So you know the probability beforehand. So such events you call as equally likely events. Okay, where they have the same chances, okay, of occurrence. Okay, either head can come or tail can come. Again, head can come, tail can come. Okay, so that such events are called as equally likely events. Okay, or even rolling a dice for that matter. So you have six sides. You know one of the side will come, and the probability is
Yes.
1/6 only. Okay, so that
1/6.
yeah. So such events are called as equally likely events, and then we have mutually exclusive events. Okay, mutually exclusive events means both cannot happen at a time. There is no chance they can happen at a time. Okay, so for example, again writing the exam, either you will pass or you will fail. Both cannot happen. Okay,
Mm.
so such events are called as mutually exclusive events. Okay, these are just some terminologies we wanted to understand before even delving further. um, Again, a probability formula is very simple. So if you a is your event, then if a gets if you get a number of times, okay, and divided by total sample, total outcome space, actually total possible outcomes is um, okay, they have represented as sample space only. Okay, so total number of times you'll get that, you will conduct the experiment, so that um, that should be the denominator, and you'll get the probability here. Okay, likewise you have certain rules. Okay, probability with addition rule, probability with complementary rule. Addition rule means if you want to when an event is the union of two other events. Okay, um, when for example, if it rains, the land will get wet. Okay, there is no doubt about it. Wherever it rains, the land will get wet. Okay, such events, okay, if you want to calculate the probability of such events, then you'll have to add the probability of both of those minus subtract the intersection of those. Okay, again, this can also be represented as union or. Okay, I think we in Python set theory we have already seen this. And complementary rule is if a event um, occurs in such a way that um, there is a complement to that. Again, passing and failing. If your chances of passing are 50%, okay, not talking about the marks but the probability. If your passing of chances of passing the exam are 50%, and then your passing of failing are also 50% only. 1 minus 50% is 50%. If you have written very well, extremely well, attended the paper extremely well, then automatically your confidence increases and your probability increases. If you then you'll say my probability of passing the exam is 90%, then probability of failing is 10%. 1 minus 9, 1 minus 90% is will be 10%.
10%.
And if you add these complements, you'll always the probability will always be 1. And then there is conditional rule. Again, we'll revisit all this, we'll understand this in depth. But we are saying if two events are dependent. Okay, here events follow each other. Okay, that is the difference. Here two events follow each other. Here they are dependent in a way that if one event occurrence of one event is already known. Okay, then what is the probability? Okay, for example, I'll give you one example. What is the probability of people eating ice cream on a hot day? Okay, so if you know the temperature today, you can predict the number of ice creams that you can sell at your shop. Okay, higher the temperature, more the selling happens. So just by knowing the probability of a hot day today, being a hot day, let's just say probability is 80% today. Okay, so you know the probability of a here. In this case, if you want to probability of calculate the probability of b given a, then you'll have to take the um, intersection of it and divide by probability of a. So this is actually an expansion of Bayes rule, which we will revisit again, just understanding the theory part. Okay. Again, likewise, we have multiplication rule also. Here, this is called as addition rule. Okay. This is multiplication rule, where you multiply the probabilities. Here you add the probabilities. So again, when a event happens such that there is an intersection between them, then you can simply multiply. Okay, so probability of intersection of two events is their multiplication, so we call them as independent events. Okay, for example, I am walking, I'm walking in the park. What is the probability that bird will come and sit? Okay, there is no problem, there is, they are not dependent only. Bird can come, bird cannot come. That is not dependent in me, dependent on how, how I will walk, right, or where I will walk. So such events which are independent, completely independent. So for such events, if you want to calculate the probability of bird coming and sitting and me walking in a park, so those can be calculated simply by multiplication. So you just have to multiply the probabilities. So we also call them independent events. Likewise, there are dependent events. Again, this is the same thing as dependent event. So dependent is, if it is too hot, people will come out and eat the ice cream. That is what we are kind of assuming. And for the dependent events, you can calculate the probability of both occurring by multiplying given probability of B given A. Okay, so these are called as dependent events. Okay, likewise, there are very simple examples here. So our sample space, or in this case, they are kind of assuming that sample space is outcome space. But anyway, so sample space is 1, 2, 3, 4, 5, 6. Okay, 6 different likely outcomes can come. That is how they are interpreting. Okay, 6 likely outcomes can come. So when you roll a dice, either you can get 1 or 2 or 3 or 4 or 5, 6, one of those two, and you are trying to find the probability of getting a number less than 5. Less than 5 means how many numbers are there? 4 are there. So 4 by 6 is the probability. Simple, very straightforward. So, and the m value is, again they have further divided, but I would like to retain as is. So for probability is 4 by 6. Okay, and you can use the equation given here. Likewise, another example is probability of getting the sum of 9 when two dice are rolled. Now for this you have to calculate the entire possibilities. Okay, what, how many possibilities are there when you roll a dice? Okay, for the first time you can get 1, 2, 3, 4, 5, 6. Okay, but this we will see as an example. I will show you in code also. But when you roll the dice the second time, then immediately what happens is, when you roll the dice twice, see, first time you can get 1, second time you can get 1, first time you can get 1, second time you can get 2, first time you can get 1, second time you can get 3, first time you can get 1, second time you can get 4. That way, if you keep on calculating, the possibilities become 6 into 6, 36 possibilities you get. Okay, out of those 36 possibilities, you have to manually calculate how many times do I get the sum as uh, 9. Okay, so for you to get the sum as 9, the smallest number cannot be 1, because if you add the smallest number and the largest number, the sum is coming as 7 only. Okay, the smallest number cannot be 2 also. Okay, because the if you add smallest and largest number, the sum is only 8. So the smallest number can be possibly 3 and the largest number can be 6. Okay, this is one
Yes.
pair, this is another pair. So this way you have to manually understand and calculate. So there are 4 ways only. So totally 4 divided by 36, you will get 1 by 9. So the probability of you getting a sum of 9 after rolling 2 dice is 1 by 9. Okay, so very straightforward. These are very straightforward. Okay, and then we also have types of probabilities. Now in types of probabilities, we have classical probability. Whatever you saw up until this point is classical probability. Classical probability is very straightforward, where in which you assume everything to be fair. Okay, everything is fair according to you. It's also called as priori or theoretical probability. So you assume that the outcomes are going to be equal. Okay, so equally likely outcomes you are assuming, and basis on that you are calculating the probability. So for example, you roll a dice, uh, all the sides have equal chance of appearing, so that way you can get 1 2 3 4 5 6. So this type of probability, studying this type of probability, is classical probability. Okay, now empirical, this is mostly what we will see when we do the calculations. Okay, now I'll talk about subjective first. Subjective probability is just dependent on their own belief system. For example, sometimes fans of a cricket team are so confident that RCB will win, um, and some other fans are sure that they will win, right? So various teams believe, their fans believe differently. So in such a case, what happens is, based on the belief system, we are kind of assuming the probability. So this is called as subjective probability, and we don't deal with this because simply because it's not, it involves a belief system which is not the correct way of calculating the probability. So this you don't see in the um, answers, or sorry, in the data analysis. Empirical probability you will see sometimes you want to conduct a thought experiment, wherein which you, instead of using a fair die, you will say one side of the die has more weight. That way anytime you roll the die, so it is likely possible that 50% of the time that weighted side will come, and the rest 50% is distributed among the rest 5 sides. Okay, so that weighted side can come on the 50% chance. So that way now the probability is not 1 by 6. The probability of you getting the weighted side is 1 by 2, and the probability of you getting a non-weighted sites is 1 by 2, and out of those non-weighted sites also you have five sites. Okay, for each one of those non-weighted sites, the probability becomes 1 by 5 into 1 by 2. Okay, so that way, so this is what kind of a thought experiment. So where you will get some, although we are not in school, we won't be calculating these probabilities, but in data analysis, always if you want to conduct a new experiment, if you want to put your thought through, and think and apply certain calculations, wherein which you assume the probability of certain event to be higher than the other one. For example, I'll give you, um, if you want to calculate the anomaly detection. Okay, in anomaly detection problem, okay, in you're doing, you have done the data analysis and you have found that 70% of the time, okay, the severity is medium, wherein which it appears like it was an anomaly, but it is not the anomaly. Okay, so in that cases you want to give higher threshold value to, or maybe decrease the threshold value. Either way, you want whatever you want to design the experiment as, you want to design the experiment in such a way, you want to calculate, assign certain threshold value basis on which you want to filter the anomalies, right? So such changing, you are manually changing the threshold now. So such calculations are done basis on the thought experiments. There you can utilize the empirical probability. Okay, so just some example. um, okay, now axiomatic probability is what is very important according to me of all this. Okay, now axiomatic probability is, there are certain rules observed by this person, and this person is very important, I trust me. um, so he has contributed um, in multiple places, even in neural networks this person has contributed. So in axiomatic probabilities, he observed certain rules and came up with certain rules. He observed that smallest possible probability is 0. Okay, that is straightforward. And the largest probability of a occurrence of a event is 1. Okay. For example, I'll give you, there is the probability can be one only if there is one single event that can occur. Okay, there are no other possibilities. Okay, so such events will have probability as one. Um for example, you again this is just coming top of my head. So if you, what happens is you take a, you people take a injection, right? People take a injection,
Mm-hmm.
the probability of needle piercing your skin is one, right? So if doctor gives you injection, the needle will go inside only after piercing your skin, right? The probability of your skin getting pierced so that medicine can be injected in your body is one, right? That is a probability. There is no other
Yes.
probability there, correct? Or do you disagree?
Yes, yes, I do agree. That's
Yeah.
correct.
And
So,
likewise the
so
probable,
it's a
yeah,
sure event. We call it as a sure event. Eh?
correct, correct, you're sure that it will happen. And the smallest probability is zero. um, the same thing, that means the something impossible. Okay, it cannot happen. Okay. um, I cannot fly. Okay, so I'm walking, if I want to fly like Superman, I cannot fly, that probability is zero. Okay, so something like that, that is impossible. Next thing is, he observed these first as first rule. Second rule is, an event that is certain, if you're so sure that it will happen, then automatically its probability increases to 1. Okay. um, and he took two mutually exclusive events that cannot occur simultaneously. Okay, so for that, union of such events. Okay. Any two mutually exclusive events cannot occur simultaneously. This is the rule. While the union of events says only one of them can occur. Okay. So you take any two mutually exclusive events. Okay, that cannot happen. Um, that means you can't pass and fail at the same time, right? So what he's saying is, if you combine the union of these two, okay, you can take the probability as only one of the probability, which I mean he is correct absolutely. So if you take either, you can pass or fail the subject. What he is saying is, the probability of occurrence of both the events is equal to the probability of only one of them occurring. Okay, either you will pass or you will fail. Okay, so that is the another rule that he observed. Okay, so this is the theory part. I have also given the link if you want to go through. Okay, I will briefly talk about this tossing of coins, because my example in the coding is what is that is based on this one only. Okay, so we will.
Where are we? Sorry to disturb. Where are we getting these links actually? Because in the explanation, we generally follow these links, but I
I
mean,
paste it in
mm,
the chat only. I always, because I know you learn from the workbook, from the
mhm.
notebook, so I put the chats here. So for yesterday's
Okay.
class also it was there only.
Yes, yes. Okay, okay. Got it.
Okay,
Fine, fine. Thank you.
okay, all right. So let's look at one example, and from here we will move on to the coding. So let's just say you toss a single coin. Okay, the probability of you getting a head is 1 by 2, straightforward, and the probability of you getting a tails is 1 by 2. Okay, look at the sample space, possible outcomes. Basically, either you will get head or you will get tail, right?
Yes,
Now if you toss the same coin twice, okay, so the probability decreased by half, because first time if you toss you may get head, or you may get, second time also you may get head, or if you get head second time you may get tail, or if you get tail you may get head, and then tail and tail. So that way probability decreased from 1 by 2 to 1 by 4. Okay, if you toss the coin twice, and sample space
yes,
also increased by twofold. Okay, now if you toss the same coin thrice, okay, probability decreased by another factor of 50%. Okay, but the sample space increased by a cubic percent, although it is appearing as though it is increasing by twice. But if you compare it with the first way, it increased by 2 to the power of 3 times. Okay, the point we are trying to make here is the sample space very quickly, it increases very fast. Okay, so that we will see. Okay, okay, for this example, let's look at what are the different ways. If you want to calculate the probability of you getting tails 3 times in a row, okay, that is one time only you got, okay, you can get, and that the probability is 1 by 8. And the probability of you getting tails 2 times is, you can see here, this is 1, this is 2, this is 3, this is 4. 4 times you got. Okay, okay, here I think they have not calculated because recurringly you didn't get. Okay, maybe that's the idea here. So the probability of getting tails is 3 by 8. Okay, and the
Two
probability of
tails. One head and
two
two tails,
tails,
not that.
yeah, one head
Yeah.
and two
So,
tails, correct, correct. So 3 by 8,
but,
and likewise the
correct.
probability of 3 heads is 1 by 8. Okay, so
Hmm.
now let's move on to the coding part.
Yeah.
Okay, so for coding, what I'm doing is, there is a library called data science. Okay, very simple, uh, very simple library. I'm still not using pandas yet. We will be exploring that in statistics, and not in the data analysis also. But this data science and pandas are 99% same. Okay, there is not much difference. So I'm using data science, I'm using probability 140. Okay, that's another library, you can check it out. Okay, um, and don't worry about this Shapley and Descartes, they are not required actually. Kind of thought of installing that. Okay, anyway, so the first thing we want to look at is, for the same experiment, we are still on the same thing. Okay, we want to look at the outcome space. Here they have used the term sample space, outcome space. I think they are using very interchangeably, but don't worry about it. Use okay, if you want, I'll also add there sample or outcome space. So what we are saying is, here iter tools we saw already in the Python, and what product does, product takes two possibilities, and basis on that it generates a list of possible outcomes. So when you toss a coin once, okay, when you make array is list of array. Okay, make array or is a function, you can use list also, either way. So you toss the coin once. Okay, if you toss a coin once, there are only two possible outcomes, or outcome spaces, or the sample spaces only two. But if you toss the coin 2 times, it is 4. And if you repeat the same process 3 times, then it increases to 8. Okay, so for this example, when it increases to 8 times, okay, if you want to calculate the probability for each one of those, what is the probability of me getting heads all the 3 times, what is the probability of me getting head twice, and then tail, and what is the probability of me getting head tails head. So that way, if you want to calculate the probability, it is 1 by 8. Okay, so in all the three tossing, you'll get the probability as 0.125. um,
Three toss. Okay. You are making use of the iter tools for defining this function.
yeah, I'm make
Taking three
yeah,
two tosses.
yeah, yeah. So I'm making
Okay.
use of
And
iter tools product, okay, to use
oh,
this values h and t, okay, for
mhm.
various tosses.
Oh,
Okay,
okay.
here I'm using one toss, and I'm repeating the experiment 2 times. I'm using one
Okay.
toss again. I'm repeating the experiment 3 times. So here what I'm saying is toss a single coin 3 times. Okay, not three
Okay.
coins at a once, not 3 coins at once, but rather one coin 3 times. Tossing
Okay. And
one
use
coin,
that thing.
yeah, one
Mm-hmm.
coin 3 times, and you will get this sample space. Now, out of this sample space, is if you try to calculate, as you can see, there are only 8 possibilities, and the
Mm.
probability automatically became um, 1 by 8. If I print this 3 props here, okay, so this is what the probability is. Initially,
Mm.
when you toss the coin, okay, because you already know you are going to toss the coin 3 times, okay.
Mm-hmm.
So the probability for the first toss was also 1 by 8 only, because you already know you are going to toss. So the second time also
Mm.
1 by 8, third time also 1 by 8.
Oh,
So
no,
you,
I didn't get the cell number 75 there. Like, three toss props is equal to 1 by 8 that we know.
yeah, yeah,
Star will be 2 NP
NP,
dot 1. And
sure, I'll show you what it is. So it is just an array, okay. I'm just multiplying, I'm taking 8 different
okay,
cases.
okay. Once. Okay,
Correct,
okay. NP dot
once,
once for
yeah,
8. Okay.
yeah. Yeah, just a multiplication to get the array.
Multiplication. Okay.
Yeah,
Mhm.
yeah. Okay, so now
Multiplication.
for the 3 task space that we have seen
Yes.
above, I'm creating a table using a table function, and I'm using a columns. Don't worry about this omega and p of omega and all of this. Ideally, you can call this as a toss event. Okay, it's a toss event and probability of a toss event. What is the probability of? Okay, basically toss event. That's what they are. New column does not match. Okay, okay, fine. I'll rename for now because maybe I've
That's
used.
okay. Yeah.
Okay. Did I do something?
I think.
Yeah,
Okay.
yeah. So I
Three
think
toss.
anyway, I may have to rerun the code. That's fine. I
Hmm.
can do that. No problem. Is equal to table with columns. Okay. Uh, okay. So in this product, the point I was trying to make was, so when you toss the coin 3 times, the sample space was 8. Okay, but if you toss the coin 4 and 5 times, okay, 4 times I have not calculated, for 5 times I have calculated, almost there are 8,000 possibilities. Okay,
Mm-hmm.
8,000 possibilities for tossing the coin 5 times. Okay, quickly the,
2 raised to 5.
yeah, no,
Mm-hmm.
because 5 times you are calculating, right?
Yeah, it will be
Sorry,
2
this is
raised
for
to 5. Right?
dice. No, this is not for coin.
Okay, 6 raised to 5.
6 raised to 5. For this is for dice.
Yeah.
I will
Mm.
write that there. For dice, um, rolled. Okay, 5 times in a row
Mm-hmm.
with 6 hits, right? Okay. So for
6 raised to
dice,
5. Mm-hmm.
likewise, like this, the possibilities for rolling the dice has increased to 7,000. Okay, when you calculate the same thing for 5 rolls, the same calculations, was just that we are repeating the number of times. What happens is, see, first time you can get one, second time also you can get one, third time, fourth time, fifth time. So that way, if you calculate it for 5 times, you're rolling 5 times, the probability, if you notice, it is equal. Okay,
Yes.
it is equal all the time.
Yeah.
Now, but if you want to take the sum, okay, sum of all the outcome space of all the 5 roles, okay,
Mm-hmm.
so that sum is calculated here. Okay, so I have just applied a sum function on that particular
Okay.
omega. Okay, so basically what I'm trying to calculate is, of all these 8,000 possibilities that I have rolled the dice 5 times, what would be the probability of me getting the sum of all the rolls as 5? So that means in order to get the 5 as the sum, I have to only have gotten 5 once, only then the my sum will be 5. Okay, I've calculated what is the probability of me getting the sum of 6. Okay, so that probability, all these probabilities are equal if you notice. Okay, for each of course, for each roll 5 times, whatever the values are there, that probability is same. But if I calculate how many times will I get 6, 6 and 6, and do a group by on top of that, okay, here I have not taken 6, I have taken 10. What is the, here I'm trying to calculate what is the probability of me getting the total sum as 10.
Yeah.
Okay,
Yeah.
so that probability is obtained here. So how many times I have obtained 10? Totally 126 times I have obtained. Now if I multiply 126 into one, this value, I will get the probability. So that is somewhere coming up to 1.62%, okay, of all the rolls. Or I'm getting the if you want to talk about in probability, 126 into 0.128.
Yeah.
Okay, so
Right.
let me
Yeah.
multiply that.
Yeah. You
126.
can.
Hmm? Yeah. Now I want to see the value. Okay, that's all. Okay, so that is coming to as 0.0162. Okay, which is same as your 1.62%. Number of times you will get the summation as 10 if you roll the dice 6 times, sorry, 5 times. Okay, with 6 sides. So this is how you can calculate various probabilities. Okay, and if you want to further take it, if you want to look at the distribution, okay, I'm getting all these sums of all these 8,000 possibilities. I'm just doing a thinking now, thought experiment. I'm thinking what could be the probability of me getting the total sum as 5. Minimum sum should be 5 only. Okay, minimum sum is 5, and the highest sum, okay, highest sum could be something else like 66666. Okay, 6 5s are 30, highest sum could be 30. So what is the, if I keep on calculating the probabilities, what could I actually observe? How many times each sum has appeared is what we are trying to calculate. Okay, so if I calculate the sum and group by some column and do the sum on top of that, then I'm seeing that the probability of all these the total sum becoming 5 after rolling the dice 5 times is this, and the sum becoming 6 is, probability is 6. It increased here, but the probability of 7 further increased, probability of 8 further increased, okay, probability of 9 again further increased, so it kept on increasing. Okay, up until what point did it increase? If I want to know, if I do a plot of these values, I can simply observe that it is a bell curve,
Normal distribution.
normal distribution. Okay, so probability of me getting sum is 5, sum as 5 is here in this bin, first box, okay, first bar. Then it increases at a certain point, and then it, from there it starts decreasing. Okay, so this is what is observed in real world also. Okay, um, so if you calculate the percentage of students securing various marks out of 0 to 100 marks in physics, let's just say the board conducted the exam for the entire state of students. Okay, and if they start calculating the uh, distribution over it, how many students got this many marks, how many students got 35, how many got 36, how many got 37, 38, 39, that way. So they will see this normal distribution. So now gradually the number of students who started securing, okay, highest
So
marks
maximum and
decreases.
minimum, yeah, maximum and minimum marks, it will have the minimum probability, and for
Correct.
the average marks, it will have the
Will
maximum
have the,
probability.
yeah, yes, that is how it is generally, that is how it is everywhere in randomly occurring events. Okay,
Nature itself. Yeah.
yeah, nature itself is like that on all the, yeah, all the random events. Okay, so further if you want to, okay, this is same, just ignore this thing. But if you want to calculate what is the percentage of times I got um, the probability, or the sum as between 14 and 21, which is somewhere here. So this is 14, if this is 15, this should be 14, right? This bar is 14, likewise this bar is 21. How many times I got these values? Okay, between this to this, that also you can calculate simply by using
Adding.
another function, applying a where condition. On top of that, you have to choose the column name where you want to apply. Okay, r dot between, in r function also you have lot of them. If you type dot and type, you can apply various conditions: above this probability or below this probability, between this probability, equal to, not above. So lot of possible combinations are there you can apply. So I have calculated only between this and this value and this value, what are the percentage number of times it occurs. So I can see the values. Between 14, the probability was this. Okay, when you roll the dice, the sum you got 14 was these. This is the probability. 15 is, this is the probability. That way 21, again this is the probability. And if you take the sum, I have taken the same thing till here, and I want to sum the probability. So that's why I have chosen the column, and on that column I have done the sum. Okay, so I will get 69.59. This number is important because we are going to get this number again in statistics. Okay, in, we call it central limit
So
theorem.
these are all the so these are all the functionalities of ITER tools, or
This is,
like
these
uh,
are the functionalities of data science that I said. That's why I have opened it.
okay, the one we okay,
Yeah,
the one we have.
yeah.
Okay, okay,
So I have given the everything just for, just with eye glance you can understand. It looks very similar to pandas, so we are not going to have a problem with different modules being used. Okay,
okay, okay.
so yeah, so you can just with quick glance you can understand how the functions are being applied and all of that. I will give this link also above. Okay, so you can just have a look.
Yeah, yeah, that will be great.
Yeah,
Thank you.
okay. Okay, so we know, now we know in the exam if they ask, I mean there is not going to be any exam. I'm just hypothetically saying, if you want to calculate the probability of you getting a certain value between so and so value. Okay, this is how you can calculate. And this is very useful, I'll tell you why. Because let's just say you got, if your management asks you, you're working on a data analysis problem, and your management asks you, okay, how many, what is the possibility that I will get, um, that I'm able to market my product very well. Okay, so and so product. Okay, and you, for that
Mhm.
you will have to, you will go on calculating what are the competitor products in the same range. Okay, what is the advantage your product has, maybe price advantage, quality advantage, okay, better marketing advantage, whatever the advantage is. So you can calculate the probability there also. So you can
So
calculate,
cumulative, basically, we can say this is a cumulative probability for
this
those
is a
events.
cumulative probability, yeah, but with a
From
condition. That is the thing,
yeah,
with a
14
condition.
to 21,
Yeah, yeah.
14 to 22. Yeah.
Yeah. So likewise, you can change the value sign, calculate the probabilities.
Very useful functions that have been discussed today.
Yeah, yeah,
Yeah.
very, very useful. And up until this point, is everything clear?
Yes, yes.
Okay. I
Thank you.
noticed that
Thank
the other folks have not joined. No?
you. They are going to miss this